Yeah. Hello. Hello. Yeah. So we'll start our class today at I guess 3:20 because people keep on joining and stuff. We'll start at 3:20 and end by 4. And I guess what I have received as a feedback is that I'm giving the solutions too much. I'm not letting people try things. So please the comments. Yeah, we'll start solving assignment 4 and just go back and try to solve as many as questions. We'll start from 3:20. Yeah. Yeah, again, so we'll start from 520 because people keep on joining in the middle. I'll stop taking people from 520. I guess this is our last class. I'll just share my WhatsApp number so that if you folks have any doubt, you can always contact. Yeah, Sandeep Sharma, do you have any doubts or anything you have unmuted yourself? Hello, Sandeep Sharma. Do you have any doubt or something? You have unmuted yourself. Okay, fine. We'll start, I guess. Okay. Are you able to see my screen? Okay. So, have any of you tried? Uh, like, yeah. So, any of you have tried assignment 4? Okay. So, we'll start from the back, I guess. We'll start from this question. Any of you? So, let us start from question 15. So, shall I give some time to solve question 15. I guess I have been fast. Let us solve few questions, but thoroughly such that everyone understands what's the thing. So question 15 is basically a discrete time. It's a difference equation. A of n plus 2, right? A of n plus 3 times n5 plus 2n minus phi of an plus 1 plus 2an. 2an is equals to 0. A0 is equals to 1 and 1 and a1 is equals to 0, right? a0 is equals to 1 and a1 is equals to 0. So can anyone just give an approach or something like that? So how do we start this question? Any attempt? Phi plus 1 minus. Shall I give you some time to work this out so that okay, I'll just give some 3-4 minutes. Just work this out and uh, can anyone of you tell me the approach? Let us do one thing. Let us calculate A2 is equals to 5 times 0 minus 2, right? Implies A2 is equals to minus 2, right? Yes, so yeah, I guess one of you was trying to answer it. Okay. So 3A3 equals, or else you can do it this way. I mean, there is one Laplace method. I'm just trying for some induction type of a method. Let's move on. 3a n plus 2 is equals to 5a n plus 1 minus 2an, right? So 3 times a2 is equals to 5a1. I'll just keep a1 and a2 like that. 2a0 implies a2 is equals to 1 by 3 times 5a1 minus 2a0 first. Next, 3a3 is equals to 5a2 minus 2a1 implies a3 is equals to 1 by 3 times 5a2 minus 2 by uh, 3 times a1. So a3 is equals to 1 by 5, 1 by 3 into 5 into uh, 1 by 3 times 5a1 minus 2a0 minus 2 by 3 times of a1. Okay, this approach, okay, you will get. So what I'm trying to do is we'll just get an expression for an and I mean inductively prove that it is true for n plus 1 and that's it. I have been actually told not to give direct solution, but so it will be helpful if one of you actually. If it were an MCQ kind of a thing, you could have substituted just A1. So 3 times 2 by 3. 2 minus 2. This doesn't work. So this doesn't work. So only this is something that will work. We'll check. N is equals to 1. Oh, if n is equals to 1, then 2 by 3. 3 is 0. For n equals 0. Hmm. Yeah, this one satisfies. Okay, next one. 3n plus 2 minus 5 of an plus 1 plus 2an equals 0. So let us try for, let us try this thing. So transform. We'll just try to use some Z transform identities. Let's see if things work out. Okay, we can use actually this one, time advance property. Z power x power k. Okay, so what is, so say if Z transform of x power k equals some x of z, then Z transform of x of k plus 1 is x plus alpha is equals to z power alpha x of z minus z power alpha into sigma is equals to 0 to k minus 1. N is equal to 0 to alpha minus 1 times xn. Xn into z power minus n. So just let us substitute this. Z of an a0 sorry a1 is equals to what? Z times a of z minus z times sigma n is equals to, so this will be from 0 to 0, so x of 0, that's it. Z of a2 equals z square az minus z square minus z square times x of 0 into z power minus 0 plus x of 1 into z power minus 1, right? Now z of a2 equals z square a of z minus z square, x of 0 was 1, x of 1 is 0, so z of a1 equals sorry, this is n plus 2, sorry, n plus 2 n plus 1 is z a of z minus zx of 0, so this is z, so you have z square a of z minus z square times 3 minus 5 times z a of z minus z plus what was that, plus 2a of z, a of z equals 0. So now you have a of z into 3z square minus 5z plus 2 equals 3z square minus 5z, right? So a of z equals z into 3z minus 5 whole divided by 3 5 3z square minus 6z plus z plus 2 what something fishy 3z square minus 5z plus 2, right? 3z square sorry, minus 3z minus 2z, right? So this is z into 3z minus 5 divided by 3z into z minus 1 into plus minus 2 into z minus 1. So this is nothing but z into 3z minus 5 by 3z minus 2 into z minus 1. So a of z is basically z times 3z minus 5 by 3z minus 2 into z minus 1. I guess we can substitute it this way. Z we can take it common divided by uh, 3z minus 2 into is you have to substitute 3 into 2 by 3 minus 5 by 2 by 3 minus 1 uh, plus 1 by z minus 1 into 3 into 1 minus 5 by 3 into 1 minus 2. So a of z is basically z into 1 by 3z minus 2 into uh, this is basically 2 minus 3 by minus 1 by 3, I guess, plus 1 by z minus 1 into minus 2. So a of z equals z into 1 by 3 times z minus 2 by 3 minus 3 minus 1 by 3 plus minus 2 by z minus 1, which is equals to z into 3 by z minus 2 by 3 minus 2 by z minus 1. So if you just take Laplace inverse of this is 3 times 2 by 3 whole power n minus 2 into 1 power n. Because this is this answer. Yeah. Okay. So I mean, let us try it by induction also. Let us try multiple approaches. Can anyone please tell me how to do this same procedure by induction? So we have a difference equation 5 times an plus 2 minus 3an plus 1 plus 2an is equal to 0. Uh, a0 is 1 and a1 is 0. Can you try to a binomial induction somehow and get things? 5an plus 2 is equals to 3an plus 1 minus 2an. Okay, so 5 times a2 is equals to 3a1 minus 2a0. Okay, keep this aside. So implies a2 is equals to 3a1 minus 2a0 by 5, right? Now let us. So I thought we cannot cover many questions, so let us cover few questions very thoroughly in multiple approaches. So okay, a2 is something that we have. Okay, so 5 times a3 is equals to 3a2 minus 2a1. a3 is equals to 3 by 5 times a2 minus 2 by 5 times of a1. a3 is equals to 3 by 5 times a2 is 3a1 minus 2a0 by 5 minus 2 by 5 a0. Yeah, sorry, a1. So a3 is equals to 3 by 5 whole square times a1 minus 3 by 5 into 2 by 5 times plus 2 by 5 a1. Sorry. Yes. 3 by 5 whole square minus 2 by 5 a1 minus 3 by 5 into 2 by 5 times of a0. Hmm. Okay, I think if you just go, okay, I'll just give an approach because from Z transforms I have solved it. Just think how to solve in terms of binomial induction. Just give A4 and A5. I think you'll see some pattern. From the pattern, you just claim AN to be true, and then from that you get AN plus 1. Then you prove it by binomial induction. Okay. Let us try that. So the partial differential equation that we solved last time, I think I was dissatisfied with that. So let us solve it again. So what is the expression? Did anyone try this question? Dou y by dou x is equals to dou y by dou t. Dou y by dou t plus y of x comma 0 is equals to e power minus 3x. So dou y by dou x minus dou y by dou t is equals to y. So basically dx by 1 equals dy by minus 1 equals, oh sorry, dp minus 1 is equals to dy by y, implies x minus t is equals to c1 and x minus t is equals to f of y, I guess. Solve this. Minus t is equals to y. Y is equals to e power minus t times f of x, right? So x is nothing but x equals to plus f of so y of x comma t equals some e power minus t into f of x implies y of x comma 0 is equals to e power minus 3x which is equals to f of x implies e power minus 3x into e power minus t is equals to y of x comma t. Yes, this is the solution. Minus 3x is 4t. There's something wrong with the question. Okay, let us try it by Laplace transform approach also. Dou y by dou x equals dou y by dou t plus y of x comma 0 equals e power minus 3x. Anyone tried this one via Laplace transform approach after the last tutorial? Okay. Okay, applying Laplace, defining Laplace transform of y of x comma t to be some capital Y times x comma s. So dou by dou x times y of x comma s should be s times y of x comma s minus y of x comma 0 which is e power minus 3x okay plus y of x comma s implies dou by dou x of y of x comma s is equals to s s plus s plus 1 times y of x s plus 1 minus e power minus 3x implies dou by dou x of y of x comma s minus s plus 1 times y of x comma s is equals to e power minus e power minus 3x implies this is nothing but dou by dou x of y of x comma s into e power minus s plus 1 which is equals to minus of e power minus of s plus 1 into e power minus 3x. This I think some issue with uniqueness and stuff. So you just integrate this y of x comma s integrating with respect to x, right? So e power minus s plus 1 minus y of 0 comma s e power minus s plus 1 should be equals to e power minus 3 times s plus 1 integrating e power minus 3x from 0 to x we get 1 minus e power minus 3x by 3 then multiplying with y of x comma s is equals to y of 0 comma s e power 3s minus entire thing into e power 1 minus e power minus 3x by 3. I think I made some mistake. There is an external here. Sorry. Y of x comma s into e power minus of s plus 1 into x minus y of x comma s sorry 0 comma s minus is equals to um, e power minus s plus 4 into x, right? If you integrate this from 0 to x, I don't understand. Oh yeah, we should integrate from 0 to x only. This is nothing but 1 minus e power minus s plus 4 times x by s plus 4, right? Make it. Okay. 1 minus e power minus s plus 4 times x by s plus 4. It would be nice if you guys also try things with me. I of minus e power s plus 1 times x by s plus 4, sorry, plus minus 1 by s plus 4. Okay, sorry, I made a small mistake. Here I guess will be having e power minus, sorry, place, sorry, y of x comma s e power minus s plus 1 times x minus y of 0 comma s is equals to, just do it, minus 1 times 1 minus e power minus s plus 4 times x by s plus 4. Okay. Dividing the entire thing by y of x comma s is equals to y of 0 comma s e power s plus 1 times x minus e power s plus 1 times x by s plus 4. S plus 1 s plus 1 will get cancelled, and less e power minus of s plus 1 x by s plus 4. Okay, now we have to take the Laplace inverse of this. So this will be y of x comma t, L inverse of 0 comma s. This is not, can't take Laplace inverse of this actually. So let us try once by separation of variables. So dou y by dou x is equals to dou y by dou t plus y. Y of x comma 0 being e power minus 3x, right? So let this be let y be f of x into g of t, implies 1 by f into df by dx should be equals to 1 by g dg by dt plus 1 equals, say, c. So f is equals to c e power x, whereas g equals mhm, f. Okay, okay, sorry. F is equals to e power cx into some c1. G is equals to c2 times e power
C1 x minus
yeah
1.
c minus 1 times t. Okay, if so f into g is some c bar times some c bar c1 into c2 e power cx into e power c minus 1 times t, c bar into e power cx plus c minus 1 t. So just take t equals 0, y of x comma t equals so e power minus 3x is equals to c bar times e power cx. So c has to be minus 3 and c bar has to be 1, otherwise this initial condition won't be satisfied. So this has to be minus e power minus 3x minus 4t. Okay, I think there is some issue with the question itself. I don't think this question has problem with uniqueness and stuff. So uh, you need to analyze it better. Let's go to next question. So basically, I thought I had to solve every question, and then I get an instruction saying, no, 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 you shouldn't solve. In fact, I shouldn't even solve the entire thing. I should just give uh, some instructions and just tell you to proceed. Actually, it's fine. Okay, let us try to solve this one. System of ODs dx by dt is equals to 2 minus 2x of t minus y of t and dy by dt equals minus x plus y. Okay, I think our tutorials will end with this question. Anyone can, so y of 0 is 1 and x of 0 is 2. Y of 0 is 1 and x of 0 is 2. Okay, so anyone can tell me how to solve this question or anything? We'll stick.
Sir,
Yeah,
both side applying Laplace and
yeah, that's it. So you're,
next
yeah.
grammar rules maybe.
So this is ss of x minus 2 is equals to 2x of s minus y of s implies s plus 2 times, so sorry, s minus 2, right? I'm just writing is that it has linear equations. So s minus 2 times x of s plus y of s is 2. Similarly, y of s sy of s minus 1 equals minus x of s plus y of s. So you just take this time and I think so you'll get another equation xs of x plus s minus 1 y of s equals 1. So these are the two linear equations. So s minus 2 1 1 s minus 1 into x of s y of s equals 2 1, and then you invert this. So x of s, y of s, yes, inverse of ABCD is nothing but DA minus B minus C divided by 1 by AD minus BC. So this is basically S minus 2 into S minus 1 minus 1 into S minus 1 uh, minus 1 minus 1 S minus 2 times 2 comma 1 implies x of s is S minus 1 into 2 minus 1 by S square minus 3s plus 2 minus 1 plus 1, right? So s square minus 2 into 3 by 2 times s plus uh, 9 by 4 minus 5 by 4. This is nothing but s minus 3 by 2 whole square minus 5 by 4, right? So I'll just solve for x of s so you can try it for other thing. Is equals to s minus 1 into 2 minus 1 by s minus 3 by 2 whole square minus 5 by 4 implies 2s by 2s minus 2 minus 3 s minus 3 by 2 whole square minus root 5 by 2 whole square. This is nothing but 3 times s by s minus 3 by 2 whole square minus root 5 by 2 whole square minus 3 divided by root 5 by 2 into root 5 by 2 by s minus 3 by 2 whole square minus root 5 by 2 whole square. Now, anyone remembers the Laplace transform of a by s minus a whole square? Sorry, b by s minus b, b by s minus a whole square minus b square. I think this is e power at into sine h bt, right?
Hyperbolic.
What? Yeah, so this is 3 by root 5 by 2 times d by dt times e power 3 by 2 uh, sin h root 5 by 2 t minus uh, what is this 6 by root 5, 6 by root 5 times e power 3 by 2 t times sin h root 5 by 2t. So this is x of s. Please compute the other term accordingly. Okay, so paragraph question. Fine, I guess we'll stop with this. Uh, I thought I had to solve all questions and stuff, and then later on knew that these are the assignment questions, and some of them are common with your present questions, and I have been instructed not to give the entire thing. So with that, we'll end today's session. Yeah. If you have any doubts, you can ask, or else you can leave. I guess this is the last tutorial. Uh, I have been told that tutorial is for 4 weeks. So yeah,
It's
you
okay,
can.
sir. Thank you, sir.
Yeah, you can leave if you don't have any questions.